Good day, children. Welcome to the session. And for this academic year in mathematics, we are going to start with rational numbers. Numbers, you have seen some types of numbers like natural numbers. They are also called counting numbers like 1, 2, 3, 4 and so on. And then we have also discussed about whole numbers. You have learnt this in your earlier classes. When natural numbers start from 1 and continue till infinity, whole numbers start with 0 and then continue with the natural numbers. So what do you understand from here? We can conclude that natural numbers are a part of whole numbers. Are a part of whole numbers because extra 0 is included in whole numbers. And then next you have seen what integers are. To natural numbers, if you add negative numbers, negative, this is how the short form of negative is written. Negative numbers, NO.S stands for numbers. So when negative numbers are also added to whole numbers, then the whole thing will become integers. So you have discussed about natural numbers, whole numbers and integers. So how you can write till now, you can say that suppose integers is a big group. Okay, within this you have whole numbers and within this you have natural numbers. So integers, whole numbers and natural numbers. So in integers you have negative numbers other than whole numbers. In whole numbers you have natural numbers other than 0. Is it not? So you have natural numbers without 0. If 0 is also included, that forms whole number. And if whole numbers are included along with the negative numbers, then the whole group will become integers. Okay, let us try to make this one different like this. It's in whichever manner you want to represent, you can represent them. So it doesn't refer to any relation with the shape, just like that. Okay, right. So integers, till now from what you have learned, if integers is the big group, in that whole numbers is the subgroup, and again natural numbers are subgroup of whole numbers. Clear? So now we are going to discuss about another kind of numbers. See, these are integers. You know, like this is the number line on which you have 1, 2, 3, 4, so on. And again on the left hand side you have -1, -2, -3 and so on. 0 being the neutral integer, positive integers and negative integers. So now the point here is, what about the values in between? So 0 and 1 you have. One is 0, the other is 1. Did you ever come across the number to be 0.5, 0.01, 2.5, 3.2 or in fractions 1/2, 1/4, 2/3? Where are all these numbers on this number line then? When you are saying this to be a number line, definitely they should lie here, right? Whichever number you are saying, that should lie here. So where these numbers are going to be on number line? So definitely only these can't be the numbers. That is the pakka. You know it very well. Because you have seen 0.5, 2.5, 3.4, something like that. In decimal values we have seen. You have seen in fractions like 1 by 3, 1 by 2, 1 by 4, 1 by 5, 1 by 6, like that. So then where are all these values? Then we have started learning about, or people have started discussing about this problem, and they have come to a conclusion of another kind of numbers. Those are rational numbers. Rational numbers. And almost all these come under rational numbers. Like how? See, rational number is defined as a number which can be expressed in P by Q form, a number which can be expressed in P by Q form, where Q is not equal to 0. So you can take any integers here, P and Q being integers. Okay, rational number. How is it defined? It is defined as the number which can be written in the form of P by Q, where P and Q are integers and Q should not be equal to 0, and Q not equal to 0. Okay, first we shall see what happens if Q is equal to 0. Now the denominator value is 0 in any fraction. That means something divided by 0 is always equal to infinity. And you can't evaluate it. You can't say that this is the value of infinity. So therefore, here the limit is Q should not be equal to 0. Why Q should not be equal to 0? Because Q is in the denominator. Whatever is there in the numerator except 0, if this denominator value is 0, then that is going to yield you a result of infinity. Then what is the value of infinity? Neither you know nor I know. So you can't say that this is the value of infinity. Therefore, in a rational number, while you are defining a rational number, we say that a number which can be expressed, it need not be always something like it is 1 by 2. Any number, any integer which can be expressed, right? Integer, this P can be integer, Q can be integer, any number which can be expressed as P by Q form, where Q not equal to 0 and P and Q are integers. I will explain you how it is. Let me take 5 by 1. So here P is 5, Q is 1. Q not equal to 0. 5 is an integer, 1 is an integer. So therefore 5 by 1, you know very well, right? That is equal to 5. Simply 5 is also a rational number. Let us take minus 3. Minus 3 by 1, which is equal to minus 3. Because anything divided by 1 gives the same number again. So minus 3 is also a rational number as well as an integer. So all these numbers come under rational number. All these numbers come under rational number. So then you may say, ma'am, when all these are rational numbers, then why again another definition for rational number? Why are we give another name to this? We can just only stop at integers, no? Because all the other numbers are the subgroups of integers. Yes, I am coming to that point now. So let me take P is equal to some 5, Q is equal to 2. P is equal to 5, Q is equal to 2. So then what is the P by Q value? 5 divided by 2. This is a rational number. Where will it lie on the number line? So 5 divided into 2 equal halves. 5 divided into 2 equal halves is the meaning of it, the sense of it. 5 by 2. Or else just apply the division. 2 2s are 4, 2 2s are 4. You are left with 1 as a remainder. Put a decimal point here so that you can add 0 to that 1. 1 0 10, 2 5s are 10. So 2 5s are 10. So you got 5 by 2 is equal to 2.5. That means it is greater than 2, that you can understand, but not 3. So now it is greater than 2 because 2 plus something else is here. 0.5 is more. So this value is greater than 2. Now on number line, if you observe, what do you have here? After 2 you have just 3. If I limit myself at integers, then I must say that after 2 what comes means I should say it is only 3. But you have another value here, 2.5. 2.5 in normal usage. So it lies exactly between 2 and 3. It lies exactly between 2 and 3. Thus we need another set of numbers as the rational numbers. Is that clear to you now? No doubt any integer can be expressed as rational number, but all rational numbers are not integers. See, this number 2.5, what you are saying, is equal to 5 by 2. You can't define 5 by 2 as a integer. You can't say that 5 by 2 is integer. 5 is integer, 2 is integer. What is 5 by 2? 2.5. You are not getting another integer here. Suppose if I take 6 by 3. 3 2s are 6. So I got 2. No harm. This is integer. This is integer. This is also integer. That means a rational number is equal to integer here. But here 5 by 2 is not integer. So therefore, but this is a rational number. This is also a rational number. This rational number is equal to integer, but this rational number is not equal to integer. So what is happening here? Only till integers we can't stop there. There are other set of numbers which do not fall into integers, but rational numbers comprise of integers. Rational numbers have integers. That means every integer can be expressed as a rational number, but every rational number can't be an integer. Every integer can be expressed as a rational number, but every rational number can't be an integer. Very, very important point. You have to keep this in your mind always. If not, you will get confused with why should we have this? Yes, we should have this because what the value you are getting here after dividing 5 with 2 is 2.5 is not an integer. Hence, we need another name for such numbers. And the name given is rational number. The name given here is rational number. So, this rational number, how are we defining it as? Any number which can be expressed in the form of P by Q, where Q not equal to 0 is called a rational number. What is the limit? P and Q are integers. P and Q are integers. Q should not be, the denominator should not be 0. So, how? Now, my number is 2.5. Okay? The number here is 2.5. Can I express this in P by Q form? Yes. My P is 5 and Q here is 2. So P by Q, 5 by 2 is equal to 2.5. So 2.5 is a rational number. 2.5 is a rational number. Okay, and now see 2. 2 can be expressed as a 2 by 1, 6 by 3. You say otherwise 4 by 2, yes. 4 divided by 2 is 2. 2 divided by 1 is 2. 6 divided by 3 is 2. So any number which can be expressed in this form, but what is the limitation? Q should not be equal to 0. So such numbers are called rational numbers. Such numbers are called rational numbers. Now here you can very easily identify everything can be expressed in the form of P by Q. See, even 0. 0 by 1 is 0. Of course, 0 by anything is 0. Right? This is what you have to remember. 0 divided by anything is 0. So you are getting 0 again. 0 falls in rational number. Of course, 0 is also an integer. Right? Minus 1 divided by 1. So minus 1 divided by 1 is equal to minus 1. So minus 1 is expressed in the form of P by Q, where P is an integer, Q is an integer, a non-zero integer. So if I take minus 68, I can divide it with 1. I will get it as minus 68 again. So this minus 68 is a number which can be expressed in the form of P by a non-zero Q. A non-zero Q. So therefore, this is a rational number as well as an integer. This is a rational number because it can be expressed as P by Q as well as integer. And now see, I'll go with one more example. Minus 3 by minus 2. P value is negative integer, Q is also negative integer. Minus 3 by minus 2. Minus minus will get cancelled. You are left with 3 by 2. What is 3 by 2 is equal to 2 ones are 2. Right? So you are left with remainder as 1. Putting the decimal point, it will become 10. 2 5s are 10. So it is 1.5. Half of 3, which is 1 and half. It is 1.5. So thus this 1.5 is a rational number which can be expressed as 3 by 2 or minus 3 by minus 2. Okay. So therefore, thus rational number is defined as a number which can be expressed in the form of P by Q, where Q should not be equal to 0. Okay, so that is how we define a rational number, and these are the examples how we call these to be rational numbers. Pause the video for a second and then please try to copy that. Yes, coming back to this, how to identify whether the given number is rational or not. One thing though, it is very clear, whenever it is given in the form of a fraction, when Q is not equal to 0, you will write that every fraction is a rational number. Very simple. Close your eyes and say whichever fraction value. If anybody asks, what is 4 by 3? Rational number. What is 5 by 2? Rational number. What is 6 by 0? No, because here 0 is in denominator, that is our Q. Q should not be equal to 0. So except this limitation, remaining all, whichever is expressed in the form of a fraction is a rational. Now the point comes here. If the values are given in decimal points, if the decimal values are given, the numbers are decimal values, how to identify whether the given number is rational or not? Whether the given number is rational or not. How to identify that? Yes. When the decimal form is given, okay, All terminating decimal numbers are rational numbers. Terminating decimal numbers. What do you mean by terminating decimal numbers? See, I'll write it as 2.5. It ended with 5. It is not continuing. It is terminated. Okay. So 1.25. It stopped. The number whatever is given here is just 1.25. There are no other digits here. So it is terminating. It is ending at 5. It is also ending at 5. Suppose it is 6.2. If the number given to me is 6.2, it is terminating at 2. It is terminating at 2. So these are called terminating decimals. So the decimal numbers which are terminating at a particular value or at a particular digit, all those numbers come under rational numbers. All those numbers come under rational numbers. Terminating decimal values. Right? Okay. Now the other one is if they are not terminating, like I'll take 0.3333 like that. So it's not terminating, it's not ending. Always you are getting 3 like that, infinite times you will be getting 3. It's not terminating, it is not ending at this point. So they are non-terminating. What is the characteristic? A rational number, if it is non-terminating, but is recurring. But it is recurring means reappearing or repeating or periodically a set of numbers are repeating. Like 3 is repeated here. 3 everywhere 3 is repeated. Such numbers again fall under rational numbers. Such numbers again fall under rational numbers. So suppose if the numbers are not given in the fractional values, but they are given in decimal values. How to identify whether the given number is a rational number or not? So two things you have to observe. One is whether it is terminating or not. These 3 are terminating, but this is not terminating. Yes, if terminating, go with rational number. Absolutely. And no need to think about anything. If the decimal number is terminating, then it is a rational number. Now the point here is, if it is non-terminating, can you say directly that it is not rational? No. You have to check one more point. If it is non-terminating, you have to see whether if the values are repeating. If the digits are repeating, recurring. So we call them to be recurring. Say 0.33333 is repeating here. And I'll write one more example here. Suppose 0.252525. What is repeating here? 25 is repeating. See, 25 is repeating. Even this is a rational number. Even that is rational number. Even though it is not, see, it is not terminating, but it is recurring. Hence, it falls under rational number. So, when it is non-terminating, what you have to check? You have to check whether it is recurring or not. You have to check whether it is recurring or not. If it is a recurring decimal, then that falls under rational number. Is there any confusion? No. Think properly. There is no chance to get confused at any point here. You have defined the integers. Now another form of number we have defined, that is which number can be expressed as b by q where q not equal to 0. Okay, so that may be either it can be expressed in the directly, that means the problem can be, you may see the problem directly with a fraction. So no problem, all fractions fall under rational numbers. So a fraction is a rational number. Now you have seen here that a fraction reduces into a decimal value. If suppose in the problem the decimal values are given, not giving the fraction, you can't sit and then convert this into this for a longer time. Just like that. Afterwards anyhow you will learn that also. Just like that, by just looking at the number, how to identify whether it is a rational number or not. Yes, whether rational number or not. So in decimal form, if it is terminating, if the decimal number is terminating, then the number is a rational number. If it is not terminating, like this or like this, what to check? To check whether it is recurring or not, means a repeating type or not. See here 3 is repeated, here 2, 5 is repeated. So thus these two, that means which satisfies this recurring condition, is a rational number, is a rational number. Any number can be expressed as decimal number, remember that. Suppose minus 3. I can write it as minus 3.0, which is equal to minus 3. If I write 4, 4.0 is also equal to 4. So any other number can also be expressed in the decimal form. Only thing is that after decimal point you will be writing 0. So thus we can simply conclude that all these numbers fall under rational numbers. So what is the other group that you have here? Suppose if I wanted to make another group, this is a big group of rational numbers. It's a big group of rational numbers. So inside rational numbers you have integers. Inside integers you have whole numbers. Inside whole numbers you have natural numbers. It is something like that. It is the smallest one group. Then next whole numbers. Then next integers. Then next rational numbers. Then next rational numbers. So this is how a rational number is defined. Is that clear? So try to understand the concept. If needed, repeat the video again and then try to view this, and then you will be able to understand it. Whenever there is a need for you to think, pause for a second and then think, try to understand, make your own examples, come to a conclusion and then continue with the next part. So if you are thorough with what rational numbers are, then you can go with the properties of rational numbers. Right, children? So the task here is only taking your own examples and checking whether whatever is being taught falls under rational numbers or not. So the characteristics of these also: terminating decimals and non-terminating but recurring. So these two form rational numbers, right? So these things just try to learn them, right? So this is for children of Modern Mission High School, Boinpalli, Secunderabad. We also give coaching to IIT Foundation. For any admission inquiries, you can call on this number 9951343026. Thank you all. So children, please pause the video for a second and then try to copy it, or take a screenshot and you can copy later. Thank you.